Today we are going to use trigonometry and a couple theorems to find all of the missing sides and angles in a triangle. So what we're going to do is really combine everything that we've been working on this week with trigonometry, and we're going to have problems where there's going to be more than one thing that's unknown. Like maybe we won't know two sides and an angle, and we're going to figure out everything. So we call this lesson full triangles. So let's jump right in and get started. Get out your guided notes. We have 4 examples that we're going to do in our guided notes. So we have this picture right here. And it says solve for the missing sides and angles. So as you can see, we have 2 of the sides. We have AC and we have BC. So at the end of this problem, I need to figure out what AB is. And then I also need to figure out the angles of A and B. So before we get started, I want to let you know that there are different ways to do this. There's no one right, correct method for solving for all these. Now, we'll all get the same answer at the end, but you might do different steps or different trig functions, and you'll get the same thing as me. So, like I said, we're going to do a combination of trig functions, sine, cosine, and tangent, and we'll do those inverse functions as well when we're solving for angles. We're also going to use the triangle sum theorem. That's saying that all 3 angles in a triangle add up to 180. And we also can use a little Pythagorean theorem as well. So let's go ahead and get started. So for this one, I'm going to solve for AB first. Okay, so I have one missing side. So when I look at this, the easiest way to figure out that missing side is to use the Pythagorean theorem. Remember that A squared plus B squared equals C squared. So we don't have the hypotenuse, but I technically have my lowercase a and b. So I'm going to write it like this. 8 squared plus 12 squared equals AB squared. So I need to solve for AB. So I'm going to simplify this and say 64 plus 144 is equal to AB squared. So I'm going to add 64 and 144, and that's going to give me 208 is equal to AB squared. So remember, we're not going to have perfect whole numbers as our answers, and that's okay. And we take the square root of both sides, and I will have this change into a decimal. I know sometimes we leave things as a radical, but when we're doing trig functions like this, we don't. So the square root of 208 is going to give me 14.4. So here you go, 14.4. So I'm going to get rid of my work right here to make more space. But don't forget with these, we always round to the nearest 10th as well. So I'm going to go ahead and label my picture 14.4. Now I need to figure out angle A and angle B. So I'll just do angle A first. There's many different ways you can do this using trig functions. I'm going to use the 2 sides that I already know. I know the 12 and the 8. So I'm going to say tan of A is equal to 8 over 12. Remember, tangent is opposite over adjacent. So if I have A right here, opposite is 8, and then adjacent is 12. So I have 8 over 12. So if you remember, what you're going to do in your calculator is say tan to -1. We're going to do the inverse of 8 over 12. And when you're doing this, make sure your calculator is in degrees, not radians. So type that in, and you should get 33.7 degrees. Okay, I'm going to label that over here. So now for that one right there, I could have used the 14.4 that I'd calculated the step above when I was looking for this angle. And if I really wanted to, since now I have the hypotenuse, I could have used sine or cosine and used 14.4 in the ratio. So like I said, you could use different trig functions, but you will get the same answer as me. Last but not least, I need angle B. So if you're looking at this thinking I could use a trig function, you're right. You can use a trig function. You could use tangent of B is equal to opposite, which is 12, over adjacent, which is 8. Now that we know the hypotenuse, you could use sine or cosine. Another thing you can use, which is probably a little bit easier, is the triangle sum theorem. You know that all 3 angles in a triangle add up to 180. And we know 2 of these angles already, so you can solve for B this way. So we have angle A plus B plus C is 180. Well, we know angle A is 33.7. We don't know angle B, and we know angle C is 90 degrees. Set that equal to 180. So 33.7 plus 90 is going to give me 123.7. So I have B plus 123.7 is equal to 180. So I'm going to subtract 123.7 from both sides. And when I do that, I'm going to get 56.3. Let me move my writing out of the way. You're going to get angle B is 56.3. So I'm going to label that over here as well. So I have solved for the one missing side that was missing, and I've also solved for both angles. Just to clarify again, there's not one correct order or method to solve these problems. You could have used different trig functions, like I said, or if you didn't want to use all these theorems, you didn't have to, okay? You didn't have to use the triangle sum theorem right here to calculate this. So if you wanted to find AB as your very first step, you would have to use Pythagorean theorem because you don't know these other angles yet. You cannot use angle C in a trig function because that's a 90-degree angle. And remember, our trig functions only work for acute angles. So they have to be less than 90 degrees. So the trig functions will only work with A and with B. Okay, let's go on to example 2. Now, if you're watching this, make sure you just pause the video, try this on your own, and then see how you do. Okay, so let's see what we have. This time we are given one angle and we are given one side. So I can't use the Pythagorean theorem right away just to calculate the other side, but I can definitely use a trig function. So first things first, I'm going to find side AB. Okay, to find that, I'm just going to use cosine of 26 is equal to, remember cosine is adjacent over hypotenuse. So that is equal to 16, which is adjacent, over the hypotenuse, which is AB. So I want to solve for AB. So when I do that, I'm going to multiply both sides by AB. Okay, that cancels out. And I'm going to have AB times cosine of 26 is equal to 16. I'm going to divide both sides. This is just like we did last week by cosine of 26, and you should get AB is equal to 16 divided by cosine of 26, and you should get 17.8. I'll get my writing out of the way to make this a little clearer. So we know side AB is going to be 17.8, so I'm going to label it over there. So let's go ahead and do BC. There's a couple different ways you can do this. Okay, you could use a trig function, or you could use the Pythagorean theorem. It's really your choice. I choose to use a trig function. So I'm going to say tan of 26. So I'm doing A right here. Tan is opposite, which is BC, which we don't know, over adjacent, which is 16. So I'm going to say tan of 26 equals BC over 16. So this one, it's a little simpler. To get BC by itself, I just multiply both sides by 16. So I'll say 16 times tangent of 26, and that's going to give you 7.8. Again, you could use the Pythagorean theorem, okay? You could have said 17.8 squared is equal to, because that's the hypotenuse, 16 squared plus BC squared. And if you do that, you will get the same thing as what we got right here, 7.8. So now let's find our last missing thing. If you look right here, we are missing our angle of B. So we have angle B. Okay, you could use a trig function. To me, it's the easiest when you have only one missing angle measure, just to do the triangle sum theorem. So I said angle A, B, and C is equal to 180. So I'm going to say 26 for angle A plus B, which is unknown, plus 90 for C equals 180. So 26 plus 90 is going to give me 116. Is equal to 180. I'm going to subtract 116 from 180. And when I do that, I'm going to get 64. So I know angle B is 64 degrees. Again, you could use the trig function in there. And if you did, you would get the same thing as 64 degrees. Okay, we have two more. Again, pause the video, try this on your own, and then check your answers with mine. Again, we're going to look for two side lengths here and then one missing angle. So I'm going to find AC first. Now that I have, or since I have angle 31, I'm going to do sine of 31, and I know that's opposite, which is my AC, okay, over the hypotenuse, which is 4. So sine of 31 is opposite over 4. To get AC by itself, I multiply both sides by 4. And when you do that, you'll have 4 times sine of 31. And that's going to give you 2.06, which is 2.1, okay? Yes, that does look like a small number, but it's okay, because if you come over here, you realize your hypotenuse is 4. So this number is smaller than your hypotenuse, which it has to be smaller. So we know that this is probably correct. Let's find our other side, side BC. Okay, again, you could do this two different ways. You can use a trig function, or you can use trigonometry. Or I'm sorry, trig function, or you could use Pythagorean theorem. Okay, I decided to use trig, so I said cosine of 31, and for cosine, it's adjacent over hypotenuse. So my adjacent is BC, and my hypotenuse is, of course, 4. So to solve for BC, I multiply both sides by 4. And you're going to get cosine of 31 times 4, and that's going to give you cosine of 31 times 4, and that will give you 3.4. Again, check. Yep, that's the right number. That makes sense, and that's definitely smaller than 4, so we should be good to go. Okay, angle A, just like last time. I have one missing angle, so I'm going to say that all of them add up to 180 because I know that's true. And I'm going to plug in the angles I know. Angle A plus 31 plus 90 is 180. So 31 plus 90 is going to give you 121. And then you're going to take 180 and subtract 121, and that's going to give you 59. So angle A is equal to 59 degrees. Okay, last one in your guided notes. Solve for the missing sides and angles. Okay, you're going to do the same thing that you've done for the other 3 examples. Pause the video, try it on your own. Okay, let's take a look at this. We cannot do the Pythagorean theorem first because we only have one side, but we can use a trig function. So I'm going to use 22. Okay, remember, you can't use C because that's 90 degrees and you have to have an acute angle. So I'm going to use 22. I do know what's opposite of it. So if I'm looking for AC, I'm going to use tan. Tangent of 22 is equal to opposite, which is over adjacent, which is AC. So I want to solve for AC. So I'm going to multiply both sides by AC. And you'll have AC tangent of 22 is equal to 3. And you're going to divide both sides by, remember, treat tangent of 22 just like a regular number. You divide both sides by that. And you're going to get AC is equal to 3 divided by tangent of 22. Okay, that's going to give you 7.4. I erase all this so we can move on. So I know that this over here is 7.4. I'm going to solve now for side AB. Okay, again, you can use a trig function or you could use the Pythagorean theorem. You'll get the same thing. So for this one right here, I still use 22 and I did sine this time. So sine of 22 is opposite, which is 3, okay, over the hypotenuse, which is AB. So again, just like what we did above, I'm going to multiply both sides by AB. That cancels out. And I have AB sine of 22 is equal to 3. I'm going to divide both sides by sine of 22 and cancel those out. And so I know AB is equal to 3 divided by sine of 22. And this is going to give you 8. It's really 8.0. So now we know, let me erase my work so we have a little bit more space. Now we know that the other side length is 8. Last but not least, we need angle measure B. So, oops, it says A there, but we know we need B, okay? So for that, we are going to say angle A plus B plus C equals 180. You can tell these are kind of repetitive. We really do the same steps each time. So for this one right here, we're going to say 22 plus angle B plus 90 degrees is equal to 180. 22 plus 90 is 112. So angle B plus 112 equals 180. So I'm going to subtract 112 from 180. And when I do that, I'm going to get 68. So I know that angle B is 68 degrees. And that is how you solve when we say full triangles. That's how you solve for all of the missing sides and angles. Now it's time to move on to Desmos to practice this a little more.